All right, well, welcome to ECE Live. I'm your host, John Roberts. Thank you all so much for joining us this evening. We really appreciate your time. Tonight is kind of a special broadcast in that we are focusing specifically on our Department of Electrical and Computer. Ooh, sorry about that. So tonight we're just going to talk about Department of Electrical and Computer Engineering. And so I'm joined by four of our bright current students who will be answering questions tonight. And we're going to be talking about life as engineering students, specifically here at UK. But before we get into tonight's conversation, I do want to make sure that you all know who you're talking to. So I'm going to have our students introduce themselves. So if you all will, just with the audience, share your name, hometown, state, major, year at UK, and then if there's anything like you're involved in, such as like design teams, and you want to share that, or any student organization that you want to share with our students, and feel free to share that as well. So David, let's start with you.
Hi, everyone. My name is David Sinabra. I'm a second-year electrical engineering student. I'm from Westchester, Ohio, which is a little bit north of Cincinnati. The things I'm involved in is the Society of Hispanic Professional Engineers, SEAM, which is the Scholars in Engineering and Management. I'm also an engineering ambassador. And finally, I'm also an RA in Woodland Glen 3, which is the home of the Engineering Living Learning Program.
All right. Donovan, you want to go next?
Sure. I'm Donovan Lewis. I'm from Paducah, Kentucky. My major is electrical engineering, and I'm a senior. Some of the things I'm involved with, I'm a university scholar, an undergraduate researcher, and the electrical lead for the UK Solar Car team. Fantastic. And I'm also a member of Tau Beta Pi.
Great. Thanks, Donovan. Joshua?
Hey, everybody. I'm Josh Ashley. I'm a senior in the computer engineering department, and I am from Louisville. I am going to go into the Masters of Electrical Engineering next semester. And in terms of organizations, I'm with the Kentucky Organization of Robotics and Automation. And I'm also a research assistant in the Unmanned Aerial Vehicle Labs.
Fantastic. Thanks, Josh. And last but not least, Matt.
Hey, everybody. My name is Matt Rufner. I'm from Estill County, Kentucky, Eastern Kentucky, a little more rural area. I'm currently a PhD student here at UK, pursuing a degree in electrical engineering. I did a master's degree in electrical engineering here previously, and also did some undergraduate engineering degrees here too. In terms of extracurriculars, I've been involved in some organizations that are non-engineering. There's a student Buddhist association that I was the president of for a year or so. That was interesting, and definitely good experience to get some non-engineering clubs under my belt. But currently, Josh and I are in CORA, or the Kentucky Organization of Robotics and Automation, and we're working on all kinds of cool stuff here at UK.
Fantastic. Well, thanks for the introductions. I'm so glad you all are here with us tonight. Before we get into Q&A, I do have just a couple of reminders for the audience. So first and foremost, I do want to make note that December 1st is the UK deadline for early action admissions and academic scholarships. So I definitely don't want to miss out on some scholarship opportunities. So be sure to get your applications in by December 1st, as well as supplemental materials, so that way you can qualify for those scholarships. Also, before we get going for tonight's conversation, I do want to encourage our audience to think about coming to visit us on campus. We are hosting in-person visits, and so we would love, if you haven't done so already, we would love to see you at the College of Engineering. And so if you want to schedule a time to come visit us, so that way you can learn more about UK's College of Engineering and actually see our facilities, then you should check out engr.uky.edu/visit. and the link should be will be shared in the chat later on. So be sure to do that if you haven't done so already. All right, so let's go ahead and dive into some questions here. Before, as we're waiting for some more questions to populate in, I'm curious to hear from you all. Why did you all specifically choose electrical or computer engineering? What is it about those degree programs that was really appealing to you all?
For
I
me,
can go ahead and
okay.
Go ahead.
For me, it was about the vast amount of experience that you can get in different subject areas, the potential to do a variety of different things, whether it's, radio communication or the development of power electronics, power systems. There really is a lot that you can do with a degree in electrical engineering. And as someone who gets bored pretty quickly, it's having a lot of different possibilities made it the right choice for me.
Makes sense.
Personally, for me, I chose computer engineering because I liked programming in high school, but then I got very interested in the embedded system side of thing, where you could actually program something and see it manifest itself in the physical world. Things like rovers or robotic arms, that kind of thing. To be able to actually make computer code that then transforms itself or moves around in the physical world was really interesting to me. So.
Yeah, for me, I thought I've always found electronics super interesting, and just like the way that society's headed, electronics are the future. Everything's becoming more and more automated, and electrical engineering is a great degree in preparation for the automation society in the future.
Yeah, I agree with what everyone said. I had a lot of free time as a kid, so I found myself taking a lot of stuff apart, and take a VCR apart, take a computer apart, take a hard drive apart, get some really strong magnets out of it. I was like, oh man, this is pretty cool. So I kind of naturally gravitated towards electrical engineering and computer engineering for those reasons, and I'm really happy to have found myself at UK for these years.
Kind of going back to something that David said, I'd like to build on this a little bit. David, you mentioned that the way in which society is moving is there's just going to be opportunities. Can you all expound upon that a little bit? Like, what kind of opportunities do you all foresee, or have you all already had through co-ops and internships that you all feel like are going to back David's point up in regards to just the need and the opportunities out there?
Oh, there's so many different directions that electrical engineering can take you. There's power and energy. You can get involved with the electric grid and the distribution of power, and that's obviously a very necessary part of our society. But you can also get involved in much more specific parts of electrical engineering that deal all the way down to the very smallest level. That's pretty large scale stuff, power and energy, but you can do smaller scale stuff like nano, like photonics, and the sort of nanoscale 3D printing that goes on at UK. You can go from the very large power to the very small optics and stuff like that.
And a lot of the electrical opportunities come with everyday objects like phones, smart devices, IoT, embedded system stuff. You find that all over the place these days. And companies really, there's a lot of companies out there that are developing new technology to integrate IoT systems with their current product line. I know I've had a co-op in the past where that was specifically what I did over the course of my time there was input embedded systems into already developed and manufactured products. So there's a big field for that. Electric vehicles, really interesting, really exciting, and things like that. The opportunities just keep developing.
Yeah, and through your coursework and even interacting with the professors in various projects too, you'll come in contact with a lot of those electrical and computer engineering companies. Like, for instance, when you use a sensor, that'll come from a manufacturer or when you use a motor or different types of software. And just through, being in that environment and getting experience with those tools, you come in contact with a lot of opportunities and directions you can go with your career. Through the UAV labs, particularly for me, I've used a variety of sensors where I've actually needed to get in contact with the people who wrote the code or made the sensor and actually talk to them about, how it worked and how it performed and that kind of thing. And I've even seen some connections grow out of that.
Yeah, like for me, even though I'm in even though I'm only a second year, so I'm like taking very basic intro courses. Like I'm already seeing like how those, like I'm in circuits 1 and a digital logic class. I can already see like how those things are like the foundation for everything in electrical engineering and how the opportunities expand with these basic core concepts learned in these classes.
And a lot of the experience that we get here at the UK College of Engineering in terms of the electrical and computer engineering department is lots and lots of hands-on experience. Whether it's the labs or activities like Cora, activities like Solar Car, the opportunities for getting your hands dirty with the skills that you learn in the classroom, there's quite a number.
That's great. Donovan, we're going to hold on to that thought in regards to more experiential learning, because I definitely want to come back and talk about that and expound upon it a little bit. Gunnar has a question for us. So Gunnar, thank you so much for joining us tonight, and I appreciate the question. Gunnar's question is, well, he says, I realize the transition from high school to college is tough, but are there opportunities for freshmen to help in research? Yeah, so Donovan, you're shaking your head yes. So can you expound upon that? Maybe that gets into a little bit of the experiential learning thing a little bit.
Yeah, so UK is a research, I think I don't remember the definition, but we focus a lot on research. I know one of my roommates specifically has had experience as a freshman pursuing undergraduate research. It really depends on how you really have to communicate and develop relationships with professors outside of the class to really get a handle on those opportunities. But it definitely is out there.
Yeah, I totally agree with what Donovan said, and that term experiential really, resounds with me, because I've worked as an undergraduate researcher for the computer science department and the electrical and computer engineering department, and it really is about those connections that you make with staff and faculty, because there are opportunities to get involved, and all it takes is just chatting somebody up, and you'll find out about them.
That's great. So did I understand you correct, Matt, that you did research for did you say computer science and electrical engineering?
Yeah, my freshman and sophomore year, I worked as the computer science, the system administrator's assistant.
Oh, okay.
And stuff like that.
Oh, cool. That's interesting, just because, yeah, it's just a little bit of a, I would expect maybe some research opportunities in like computer engineering, electrical engineering, but you're, also working with another department in computer science, which is really cool that you're able to be kind of interdisciplinary.
That's the beauty of computer engineering to me, that you get to kind of dip into the software and the hardware. Yeah.
Yep, absolutely. Yeah, good point.
As
Yeah,
an
that's
electrical, sorry.
Go ahead, Donovan.
As an electrical, I also got involved in some material science research, looking at the electrical properties of nanoporous materials. So there's definitely a lot of different opportunities there for interdisciplinary research work.
Yeah, it goes back to the topic of how everything's starting to move towards electronics and embed everything, right, with the IoT. Like my undergraduate research and what's going to turn into my graduate research now, I work with the mechanical engineering department and the agricultural engineering department to implement some logging and embedded systems into these UAVs that they design and fly. So I'm kind of all over the place in the college, but I still get to work on my computers, which is cool.
Yeah, that's a great point. Yeah, electrical and computer engineering really touches everything because I mean we're all using electronics in some form or fashion. So yeah, you can really be interdisciplinary in some ways, which is I would think as a undergraduate student coming in that would be somewhat appealing. So yeah, that's great. Maddie, thank you, Maddie, for being with us tonight. It's great to see you here. She asks, what does the course load? What does the course load look like for this specific type of engineering?
I can say so far for me, I average about 17 to 18 credit hours, but that's because I'm also in the honors college, which adds some courses. But I think on average, it's usually about 15 or so credit hours a semester. So it sort of depends on like if you're involved in the honors college or SEAM, that'll add a couple credits. So it sort of varies, but it's usually at least around 15, 16.
Yeah, and through the catalog and how they have it laid out for you semester by semester actually ramps it up for you really nicely too. Everything kind of follows each other, and you don't really get two really difficult classes in a given semester. They try to dole out the difficulty into smaller portions.
And I mean, if you're taking 15, 16 hours, that's credit hours. That's generally close to how many hours you're going to spend in the classroom per week. So maybe double that, triple that for homework. So you're only over a full-time job taking that many hours.
Okay, I have another question coming in from Katie. She asks, are there internship opportunities open for first years? Curious to know if you all have any experience with that or know somebody that has any experience with that.
The opportunities are definitely there. They're not as available because you just don't really have the course load or the experience. I originally had an internship for this past summer, but the company that I had it with was going through restructuring, and then after the restructuring was finished, I unfortunately didn't have the position afterwards. But the opportunities are definitely there. So like just look for connections, either like with like if your parents are engineers and they know other people, like that's how I was able to land my interview. My dad had a friend with that company and was able to help get me an interview with them. So if you're able to find connections with faculty or like parents and friends, that'd be a great way to start and looking for those.
Yeah, it seems like the general trend is the opportunities really start opening up, especially for the UK co-op program around your sophomore to junior year is when they really start recruiting you. And there's plenty of opportunities there.
Yeah, Katie, thanks for the question. One thing you could do too is we do have a career services office here within the College of Engineering. And so working with them pretty early on to, identify those opportunities. As David was saying, they're out there. You just need to kind of be proactive and work on it. And so you can always get help within the college and our professionals too to find those opportunities. So thanks for the question. Glad you're here with us tonight. Hunter, Matt, this is going to you. He says, Hunter, I'm excited that you're here with us, and I appreciate the comment and the question. He says he wants to know more about computer engineering and computer science because both interest him. And so he, sounds like you've had a little bit of experience with both. I'm sure any of you all can kind of talk a little bit more to that. So, but Matt, I'll kick it off to you first. If you can just share kind of your experiences with both so that Hunter can learn a little bit more.
Sure. So as an undergraduate, I actually got a degree in computer science, as well as computer engineering. And I got to take the capstone design, after your 4 years of taking a major, you have to take a final design course. And there's a separate course that computer science majors take than what electrical and computer engineers take. And the electrical and computer engineering final design course is a bit more rigorous, but the computer science one, you don't really get the chance to work with your hands as much unless you're typing. So you kind of have to think, well, do I want to work with hardware as much or at all? And if that answer is yes, then you should probably pursue a computer engineering major as well, and possibly get a minor in computer science, or even major in computer science as well. It can definitely be done. The course load does not increase that much more because there are classes that count for both majors as electives, and it's definitely geared towards the content sharing. So if you don't know whether you want to be a computer science major or a computer engineering major, then it doesn't hurt you to take classes for both, because the electives will count in favor of each, and you can decide a little further in.
Awesome. Thanks, Matt. I guess I didn't realize that your undergraduate degree was in computer science. So you clearly are the person to answer that question from
I mean,
Hunter.
technically,
So hopefully
I had undergraduate degrees in computer science and computer engineering and electrical.
Oh, okay.
But that's math.
Well, and that's a good point. And I appreciate you. I appreciate you. Making that. Making that comment to Hunter. There's different ways to do it. So,
Certainly.
In your case, double major. There's the minor option for computer science as well. So it's not like necessarily it has to be completely black or white, one or the other. There's some opportunities to do it a little bit differently. That's good. It hasn't come up yet in questions, but I'm curious to hear a little bit more about some of the design teams that you all are interested, or that you all are part of. So I know we've got members of Cora here. Donovan, you've been involved with Solar Car. So can you all tell us, give us a little bit of insight into what that experience is like in terms of being involved in the design team, and kind of how that's really enriched your experience here at UK?
So I'm the electrical lead on the UK Solar Car team, and what we do is we design, build, and race solar electric vehicles on a track style competition or an endurance style competition. And when it comes to the electrical side of that, that's a lot of power and control. So we get a lot of hands-on experience with handling the power and control of pretty complex systems. I mean, we work with a solar array, we convert the energy into all kinds of other stuff, store the energy, you got to use the energy. So we get a lot of hands-on experience with things like soldering PCBs, constructing embedded system architectures for control all across the car. And it's a lot of good hands-on experience, which I've been able to directly apply to internships and to my research experience. When I came into my internship and had the experience with designing and creating and implementing embedded systems, they were incredibly impressed, incredibly amazed with what I had learned both here at the UK College of Engineering ECE department and from my experience deploying those skills and techniques from Solar Car. So it was able to directly integrate what I had learned in the classroom with experiential knowledge from being on the design team.
For Cora over here, we have a lot of the same kind of designs and design goals as Solar Car does in terms of constructing embedded systems. But what we do is we actually compete in these robotic competitions across the nation, and there are a variety of them that we have been registered in now. And so what we do is we spin up these embedded rovers that complete certain challenges like localization and mapping of its environment, as well as different sensing goals and manipulation goals. Like, for instance, we participate in the NASA Lunabotics competition every year, which is a national robotic mining competition that is in line with the 2024 Artemis missions to go to the moon. So a lot of the parameters of that is, can this robot feasibly operate in space? Can it dig up lunar-like soil? can it traverse lunar soil, that kind of thing. So
Yeah, we're a relatively new club. I don't know, Donovan, how many years has Solar Car been on the track?
I think it's 1999. So we just recently had our 20th anniversary.
Yeah. So Solar Car is old enough to drink a beer, and Cora is still in diapers. But we're proud of what we've accomplished. Like Josh was talking about, we were able to successfully compete in the 2019 robotic mining competition in Tuscaloosa, Alabama, with 50 some other universities from around the nation. I know University of Anchorage had to take their robot apart and put it in suitcases in order to fly it to Tuscaloosa and then put it back together to compete in this competition. So people are dedicated for this. And we're also trying to go into a few new competitions this next year. Hopefully they'll be hosted in person. There's one at the University of Michigan in Rochester, I think. And it's an intelligent ground vehicle competition. So it's more autonomous driving goals and navigating a track with some traffic kind of thing. But we are also a very hands-on club, much like Solar Car, in that we solder PCBs and design PCBs and work with wiring harnesses and have specific software goals to work with this hardware that we build, like some of the localization and mapping that Josh was talking about. And we're multidisciplinary as well. You know, we have mechanical engineers, computer science majors. I'm sure Solar Car has some materials, and they do a lot. They are really into the materials and computer science, mechanical engineers, obviously. So it's a great chance to get involved.
Yeah, the teams working in these design teams, that, you know, team is an important part of the whole design team phrase.
Right.
I mean, development of soft skills is pretty necessary for effective implementation of systems electrically within a multidisciplinary team, like Matthew had mentioned previously. And we do interact with a lot of people, just like, you know, typically on a job, you're going to be interacting with people of all kinds of disciplines, and being able to translate your knowledge to other levels and communicate in between, even though you don't know the in-depth level of certain topics, is essential for effective work.
Yeah, as you all have mentioned already, this is can be very valuable in terms of kind of taking what you all have been learning in the class, applying it to these designs, and then taking that on to, yeah, co-ops, internships, full-time jobs, whatever. I mean, that certainly is makes a lot of sense, and that's a great way to prepare. How does a student go about getting involved in these in Solar Car or Cora or some of these design teams?
Well, there's a great resource called Involved, which is the home for all student organizations at UK. And it's a wonderful website where you can see all of the events and members and opportunities that are in a specific club, as well as peruse any clubs that might interest you. And that's, in these times, especially the main way to get involved with these clubs.
Real quick, I've got a question from Caleb. Caleb, thanks so much for joining us tonight. Caleb asks, is electrical engineering based on a lot of physics?
So yeah, a lot of electrical engineering is based on electromagnetics, for sure. Electromagnetic physics specifically. I don't know about any of that that motion stuff, but electromagnetics, there's a lot of it in EE.
yeah, some fundamental circuit elements, like you actually begin by learning them in physics 2 before you actually see them in your electrical engineering course load. So they make physics 2 a prerequisite of some of the electrical engineering courses like AC circuits, so that you get exposed to the actual physical construction and properties of things like capacitors and inductors. So they become fairly crucial to your learning, since they're a foundational piece.
Yeah, like for me, like for example, in like my circuits class, we'll like be solving problems with like capacitors and inductors and like doing the numbers for that. But like by taking physics two with that, it sort of gives me the background of how those things work, and that gives you an idea of like how that goes into the circuit. So having that having physics two with the circuits, it helps really go full circle and understanding the knowledge of how these different circuit elements work.
Awesome. Thanks for that. And Caleb says, that's cool because Caleb likes physics. So fantastic. Probably a good fit then. Yes. Maddie asks, how has COVID determined the hands-on activities / learning at the university and the internships as well? So yeah, especially you all that have been involved in design teams. Yeah, how have you all navigated, you know, the whole COVID-19 thing?
Taking the proper precautions. The university provides very helpful resources and guidelines for the precautions that need to be taken for student organizations in order to continue in-person activities. And so as student organizations, we follow those. And one major thing is communication. I've sent more emails this semester than I have in my life, just because, you know, you don't see people in person, so you got to communicate still.
Yeah, I know some departments, they've gone along the lines of going towards, in terms of labs, they go through the lab, like the TA will go through the lab and then they'll show the student and then they'll give them the data to do the manipulation afterwards. In EE, we're still going through labs. You know, everything's properly distanced, but you still get the hands-on experience that you would typically get from within your coursework there. In terms of internships and co-ops, those opportunities are still out there. The same roommate as before, he's a sophomore in electrical engineering, and he is currently on a co-op with Intel, and then he's going to have another one with GM, and that's all virtual. So as a sophomore, he has a co-op with Intel and then a co-op with GM, or an internship with GM right off the bat, all virtual. So he gets to sit at home and learn all cool stuff all day. It's pretty nice.
Yeah, it's not bad. I guess I hadn't thought of co-ops and internships being virtual and that being an option. So, so that's great for our students, for sure. And correct me if I'm wrong, Josh and Matt, but you all are still preparing for a competition, correct? For Cora?
Right.
So how I mean, have you all been just going about somewhat business as usual, but with safety precautions? Is that how you all have tackled that?
It's a hopeful business as usual, because as far as we know, competitions are happening. In the case that there's a virtual competition, then basically all we have to show for all our design work is what we've written up about it. So it really emphasizes documentation more so than anything.
A big goal of ours this semester, when we found out it was going to be going all remote too, is to really well define the objectives of the club by the end of next spring semester, and get people specific tasks that they can do, tangible things that they can do, such that they don't need to maybe have an active dialogue in the lab or something, so that they can be at their desk or at home or working virtually and still have content that they can work on with the club.
Well, that's good. I'm glad you all are still able to have some resemblance of competition and being able to still do things that you all like to do. So moving on, Rachel has a question about senior capstone. So Rachel, thanks for your question, and I'm glad you're joining us here tonight. So Rachel asks, what are senior capstones like? And specifically, she wants to know what were your projects or what are your projects? See some smirks and some smiles, so I'm excited about this.
Electrical and computer engineering senior design focuses a lot on being able to communicate your designs and being able to document your designs as you're going through the research and development process, which is pretty important for the patenting of things or securing intellectual property if you were to go down an R&D pathway. And communication in that manner is also very useful for when you get out into the work world. And like I was saying before, are communicating with interdisciplinary teams. You need to communicate all these ideas, all these concepts. So that's really what ECE CPE senior design is focused around. Is you're given an idea. Like for me, I was given a soil moisture, outdoor wireless soil moisture sensor, and then you develop the requirements. You document that pretty thoroughly. You develop how you're going to split the project up into various teams or various subsystems, which are dispersed to individuals, and then they work on their individual components. And then at the end of, or at the start of your second semester, at the end of your first, you're sort of integrating the components together and actually coming up with a workable prototype that satiates the problem you were given at the beginning of the year. But it is focused a lot on documentation and communication of ideas, the development of these soft skills to complement the technical.
We lost your audio, Donovan.
Okay, I think, can you hear me now?
Yep.
Okay.
Donovan, I don't think we caught the last little bit of what you said.
Where did I end at?
You're talking about soft skills.
Okay, so it integrates soft skills with the technical skills that you develop through your undergraduate curriculum. And yeah, that's basically it.
Yeah, I actually got an interesting experience with my senior design project, which I'm in the latter semester of. So we're very close to finalizing the project. But I got an interesting experience because the semesters before, I actually took a year-long co-op, and I got to see how the business itself actually went through the entire project life cycle of what they called a project proposal plan through to fruition, basically to the project maintenance plan, where they would maintain whatever software or product they had created in that time. And the resemblance between that co-op and that project lifecycle versus what actually is going down in the capstone design is actually fairly accurate. So it does teach you, and what was new to me in the co-op was the amount of documentation. The rest of your classes outside of the capstone design, you'll write periodic reports, maybe a few papers, but the level of detail and documentation you need to do to actually create, release, and maintain a project is only really truly covered in capstone design, and they do it fairly accurately.
There's definitely a lot of writing involved. I can speak to my CS capstone experience, which, these guys are talking about 2 semester long experiences. So the ECE capstone, the EE capstone is 2 semesters long. And the first one, mostly documentation and project design. Well, there's always documentation, but project design, the second one is more focused on building. But the CS senior design, you have to do them all in 1 semester, and it's a little more compact. My CS senior design was designing a portfolio management system, which was essentially a way to help staff and administrators keep track of submitted PDFs and documents for coursework throughout the semester per class. And it was a neat project, but you had to get it all done in 1 semester. And with the same requirement of all that writing, it really compresses your schedule. Something to keep in mind.
Yeah, that's a senior capstone seemed like a really great opportunity to kind of have Josh. I like how you put it, and it kind of reflected what your experience was in the co-ops, and so it's a great opportunity to prepare yourself for that next stage after UK for sure. Switching gears a little bit, Caleb asks, how is it like being in the honors program? So, David, I'm going to kick it over to you to talk a little bit about your experience with the honors college.
Yeah, honors is really cool. Like for me, like it's a little change in how classes are. Like instead of taking like a bunch of technical classes, like a lot of like my last semester I took honors 101, which is a very discussion based class. So it was like we did some readings and like discussed about it in class, and that for me was really fun. It's a nice change of pace. And then also being involved in Scholars in Engineering and Management. That's a pathway in the College of Engineering, which puts you on a track for a 1-year MBA once you finish your undergraduate degree. So in addition to my electrical engineering course load, I'll be taking some business classes. Like it's usually about one a semester or so, roughly, and that will satisfy some of those requirements for that MBA. So it'll be shrunk down into just 1 year.
I was also a part of the Honors College in my first couple of years, and it's really a good program for expanding your perspective about different things that you wouldn't consider normally in engineering or technical coursework. So I had a junior level philosophy class first semester freshman year, and I learned so many different things which I would never have had the chance to learn of in these more technical engineering courses, but really brought a new, fresh perspective to how I looked at everyday life.
Donovan, that's interesting that you say that. Can you provide some examples as to, you say that it changed your perspective in some ways. What are some examples, or even some examples like within engineering that you saw that difference?
So it's just a whole different mindset. I mean, the class was mostly discussion based, and every time we entered into the class, we had to come up with 2 questions. Now, typically that's not too hard, but these are very, very abstract thoughts or abstract ideologies that you're going into. And Eric, my professor, he wanted very, very in-depth questions. So it was more about breaking things down in different, in abstract ways. And it paired with the technical aspect of things, it helped me to develop a better analytical style when it came to asking thorough questions that really get into the meat and bones of what's going on around me. Yeah, so honors is definitely a good way to broaden your perspective on various aspects of society and how they integrate with engineering methodology in terms of technical development.
Yeah, and like just one more thing to add on to that. I think just being in the honors college, a cool thing is you just get to meet people who aren't in engineering. So it's like a nice mix of majors, and it's just a great way to like see new perspectives and have new opportunities. Like for example, like one day we were like the honors college will have speakers come in pretty often, and one of the speakers was talking about U.S.-China relations, and that was something that was like really interesting to me. And so I got to learn about that, and I was one of the few like students I was like really interested in it. So I had the chance to go out to dinner with him, the professor and the dean of the honors college. So like just being in the honors college, like it gives you a chance to like a bunch of new opportunities to meet new people. And it's a really cool experience.
Well, there you go.
Yeah, that is a unique experience. Yes, not every day you get to do that for sure. That's awesome.
Dean Brady, totally cool dude. I know he's like the interim dean of the College of Arts and Sciences now, but still, they've got some cool faculty out in the honors college for sure.
Yeah,
Lots of
yeah,
really
for sure.
interesting conversations.
That's good. So something we really haven't talked. Well, hold on. Before we get to that, Caleb says that he said he saw something that said that there are study abroad programs for honors college, and he's just curious to know if study abroad opportunities are just limited to the honors college, or there's opportunities to study abroad more generally. Don't know if you all have had that experience yet.
I know of a friend who did a internship in Germany with BMW, and they were
Oh, really?
Major. Yeah, it was a year-long thing, and he was computer engineering. Yeah, he graduated 4 or 5 years ago, and it's like a year-long internship in Germany. Yeah.
I also seem to recall a few people doing their Calculus 4 in Germany as well. Yeah, so that was over a summer, I believe, is when they did it, and it was a study abroad where they did Calculus 4, and I think also they had German courses as well. So that's also an interesting avenue if you want to learn calculus in a different country.
Yeah, all the people that I've talked to that have gone through that love that program, love that to bits. They were able to explore all around the local area. Another opportunity for the College of Engineering is there typically is a renewable energy course in Spain. I've heard quite a few people that have gone through that on the electrical side of things, and they loved it as well. Going to different countries or having those study abroad experiences also works to broaden your perspective on how things really integrate technical ideas from your engineering curriculum and society as a whole.
And on that note, there's a engineering student organization called Engineers Without Borders that travels to all kinds of countries to do work with renewable energy and quality of life improvement around the world. So that's certainly something to get involved in as well.
There are also some undergraduate undergraduate research opportunities that allow you to travel to different places. I know usually they're within the country, but we were actually going to go before coronavirus hit. We were going to go to Argentina on a launch campaign for the Unmanned Aerial Vehicles Lab, and so that would have been a 2-week excursion down to South America, where we would have been launching balloons into the stratosphere.
So Josh, you've been a part of our UAV lab?
Yes. So I work with Dr. Bailey in the mechanical engineering department, and I am one of the main embedded systems architects that design the logging systems that goes in those planes. So they design the flight controls and the actual chassis that they want to put up in the air, and then they have these specific sensors that they need data off of, and I design the software for those.
Very cool. That's a neat work that they're doing in that lab, and just in general, that's just a cool lab to go and check out too, for sure. Caleb, back to your question. So as you kind of heard everybody kind of share some bits and pieces of knowledge there, there's all kinds of study abroad opportunities, and it's not just just the honors college students that get to benefit from that. There's work opportunities. You can take classes, engineering classes. You can be a part of engineering organizations to be able to travel as well. But then there's also just more broader than that. There's some other opportunities across the university as well. So if studying abroad is something that you're interested in, you'll have some opportunities within the College of Engineering to be able to do that for sure. Yeah. Can you all take me back maybe to a little bit more broad and moving a little bit away of just a department specific, but why UK? Why was it that you all chose to pursue your degree at UK? Was there something in particular about the University of Kentucky that really stood out to you, or try to take yourself and put yourself back in those shoes? What was it about UK that made you all come here to pursue electrical and computer engineering?
Well, Kentucky is pretty awesome, first of all. I really like Kentucky. I might be biased, but one of the things that made me decide to go here, well, to be honest, was scholarships. That was a major influencer. Second of all, they were ABET accredited in electrical engineering, computer engineering, and computer science. And some other universities that I were looking at that had those programs, they weren't necessarily accredited. And if you want your degree to be worth something, you want to have a degree from an ABET accredited institution. So that was certainly something I was looking for in UK.
Yeah, for me, UK was the first university I visited. It originally wasn't on my radar, but my dad encouraged me to come visit, and I fell in love with it. There's just so many things to get involved in. One of my big things I really liked was the Innovation Center. How you can I love 3D CAD design, and so just being able to 3D print things, that's something that was really cool to me. And like Matthew said, UK has some really, really competitive scholarships. And me being an out-of-stater, UK was the best for me monetarily. It was even better than the in-state schools. So definitely look at the scholarships that UK offers, because they're really good. And I'm very happy with the decision I made to come here.
Yeah, I actually came in with a pursuit of undergraduate research as well, because I heard that was an opportunity at UK. And I went to one of the info sessions. I think it was led by Dr. Dietz. He's one of our major research professors here. He's a great teacher that you'll run into in your latter semesters of ECE. And he took us on the tour specifically of his supercomputer lab, where he designs network topologies, basically, so network structures. And he walks us into this giant room of wall-to-wall server racks of computers, and I forget the number. He's like a 22-ton AC blowing cold air through this room, and I just look at it and I was just amazed. I was like, wow. And he goes, yeah, my undergraduate research students work on this for their papers and such. And at that moment, I was like, okay, this might be a pretty cool university to do some research at. So.
All right, we got a question from Sarah. This is going to you, David. But after David answers, the rest of you all feel free to chime in, because I'm sure you all have had experiences with this too. So David, what is the coolest thing you have made with a 3D printer?
I'd say one of the fun things, there's the great thing about 3D printing is it's a humongous open source community. So there's tons of different things you can find. For example, I coached a Little League baseball team this summer, and one of the kids was a huge fan of Star Wars. So I found a Millennium Falcon model, and I 3D printed that. And I also 3D printed this Baby Yoda, which I also painted. So it's a 3D printing is just a really cool technology, and it's another thing with electronics. It's sort of like the future of where engineering sort of headed. So many things are being 3D printed. Just one thing off the top of my head, the new 777X, the engines on it, a decent amount of those components are 3D printed also. So 3D printing is another interesting field in engineering that is really expanding.
Donovan, Matt, Joshua, anything to add? Oh, here we go.
So this is related to 3D printing in that this is Cora's giant 3D printer that we're building. So this has been designed by one of our club members, and it's currently in the works, and it'll have a build volume of 1 meter by 1/2 meter by 1/2 meter. So the original idea with this was to actually print the robot. So the NASA Lunabotics competition this year, They shrunk the size requirements of the rover down and the weight requirements. And it really took everybody back to the drawing board. And we were thinking, in order to get the structural properties that we want and fit it in the size constraints, that 3D printing would really be a good option for us, especially because of the materials that we could print with this. And I'll let Josh talk more about the materials, but we call this the big format printer, or BFP. And this is Cora's most recent endeavor here.
Yeah, so essentially about that question, I'd ask you to ask me in about 3 months what the coolest thing I've ever 3D printed is, because it will likely be a very large lunar rover frame that will be printed out of polycarbonate. So that's a more exotic 3D printing material. It's technically still a thermoplastic, but its most important property is that it maintains its structural characteristics in a vacuum and in extreme temperatures. So that's one of the main reasons we chose it, because it has to kind of be space grade, right? And so we're going to be printing in that, and it's going to require, I think, an extruder temperature of 400 degrees Celsius. So it's an interesting engineering challenge, but we're making it work.
Personally, I haven't 3D printed much, but for senior design, I have to make a capacitive moisture sensor. So I made some test PCB capacitors using the mill at the Innovation Center, which I hooked up to an LCR meter to check out the capacitance, basically the amount of energy it can hold in its electric field. Because the moisture in the soil changes the capacitance of these PCBs due to some electromagnetic physics 2 stuff. So that's really what I've gotten up to recently.
That's all super cool things. So yeah, I appreciate you all having some examples there on hand. That's super helpful. And just to make sure that I'm clear and that the audience is clear. So for Cora, you all had to build that 3D printer. So that's a custom 3D printer, correct?
We designed and built it ourselves. So we basically just had the idea. We had the requirement of build a meter by half a meter print bed, and particularly one of our members did an amazing job of actually throwing it up into a CAD design that we then all kind of jumped on and executed on build.
Super cool. So we are coming up on our 1 hour time frame. And so just to be respectful of everyone's time, we're going to start wrapping things up. But before we do, I would like for you all to share maybe one piece of advice that you have for everyone in the audience who's thinking about maybe pursuing electrical computer engineering. What to be successful, what's your one piece of advice in being successful in pursuing electrical or computer engineering, or engineering in general?
I would have to say, make it a hobby. Don't just do it for school. If you want it to be good, do it after school too.
I would say just there's going to be tough times in engineering. Just don't give up, and then just find like a good core group of friends that you can study with. A lot of my closest friends are in engineering, and that just having good study groups is really helpful and beneficial.
Yeah, I agree with David on that one. Making connections with the people that you're in classes with, your professors, pretty much anyone that you can reach within, an arm's length or 6 feet in COVID times. That's those connections will help you in ways you don't even think of at the moment. So making connections with people is probably the most important thing when it comes to success to me.
And then I'm going to be a little overly practical with my answer. And I wish it was phrased like this to me earlier on, but my answer would be going to classes saves you more time than it's worth to skip them. So like, 50 minutes of going to lecture is worth the 2 or 3 hours you'll be alone trying to catch up for whatever that is. So it's actually a time saver to go to lectures. So
Man's wise beyond his years there.
Well beyond your years. Yeah, very, very wise words. And I appreciate the advice for the students in attendance here. So with that, we're going to wrap up. But before we do, I've just got some housekeeping things. First off, thank you all so much for joining us. Hopefully this has been highly beneficial for you all. If you all ever have any questions about anything we covered or didn't cover, feel free to contact us at visit@engr.uky.edu or text us at 859-267-1877. So both of those pieces of contact information will be in the chat over on the side. For anyone who's interested in learning more about UK's College of Engineering or our Department of Electrical or Computer Engineering, we encourage you to register for an information session with us. I shared with you earlier to come to register and learn more about those opportunities at engr.uky.edu/visit. That link will also be in the chat, so definitely check that out so that you can visit us on campus and really see things for yourself. For updated content about how our faculty, alumni, students imagine what is possible at the UK College of Engineering, definitely check us out on Facebook, Twitter, Instagram, or YouTube, or visit us at engr.uky.edu. I also highly encourage you all to follow UK Solar Car Team and Cora on social media as well, because they are doing some really cool things, and you definitely don't want to miss out on that content either. As a reminder, December 1st is the UK deadline for early action admissions and academic scholarships. So definitely make sure that you get your application in, supplemental materials in, so that you can take advantage of those scholarships. All right. Thank you all again for joining us for ECE Live, and we hope to see you on campus soon. Go Cats.